Okay, so in this video we're going to just quickly go over the rules of significant figures. So the first thing we have is that non-zero digits are always significant. So if we had 1,151, this would have 1, 2, 3, 4 significant figures. Okay, if you were to have a number like 32, that would have 2 significant figures. Numbers are not always made of non-zero digits, however, so we need to cover some rules with those. The zeros between non-zero digits are significant. That means is if we were to have 1,000 instead of 1,151, let's say we had 1,051, this would still have 4 significant figures. The third rule is that zeros to the left are not significant. So if we were to list that number as 001051, this would still just have 4 significant figures. So those don't matter as far as counting the significant digits. Okay, only the inline zeros do, and a couple other cases coming up. The fourth rule that we're looking at is when the number is greater than 1, all zeros to the right of the decimal are significant. That means that if we were to have the number that was listed as 1051.00, we would now have to consider this as 1, 2, 3, 4, 5, 6 significant figures. Means that something like 1.00 has 3 significant figures, while 1 only has 1 significant figure. Okay, so if we move that out of the way, and if we're looking at another example of this, it also means that anything that's in scientific notation this is following on this rule of it's a number greater than 1, all zeros to the right of the decimal. Essentially, you assume anything in scientific notation that's listed is significant. So in this case, we have 1, 2, 3, 4, 5 significant figures on this number. Okay, the 0 to the right here is considered significant. Okay, and since scientific notation are always written as a number greater than 1, then we can just consider that the zeros given in scientific notation over there to the right of the decimal are going to be significant. The last case we hit is a sort of complicated and hybrid case, and you notice the may or may not. Not a very helpful rule because it's not always clear as to what you do. It's going to depend a little bit. So if we had our 1,050, okay, instead of 1,051, let's say we have 1,050. Well, here we have a no decimal point and a 0 to the right. It's not in scientific notation, so we can't look to see if it says 1.05 times 10 to the third or 1.5050 times 10 to the third, both of which give us an idea as to what we're looking at for significant figures. So in this case, it might be 3, it might be 4, and you sort of have to take a little bit of context with it. If this was the number of students in the school and you knew that they were counting every individual student, you would probably say, okay, that's counting every single student, that is 4 significant figures. If they said that the school had about 1,050 students, you would assume they were probably rounding at the end, and so you might go with 3 significant figures. So this is a little bit of a gray area, and it's going to depend a little bit on the context of what you're looking at. Always feel free to ask sort of clarification as to what we mean by that and how many significant figures we want. But in general, as things get bigger, you're going to put them into scientific notation anyways, and then, you know, if it was 1,050,000,000, the scientific notation of it would be 1.050 times 10 to the something, and that would sort of clear up the ambiguity that's left here.